Hi, so quick video so I can tell people what's been going on with my synthesizer project. There's a lot of people have been asking me about it, and I've been getting bits and pieces of time here and there, but it's been a real struggle with looking after Robin and everything to make progress, but done quite a lot now, I suppose. I've been basically developing on a pretty large breadboard. Started off with basically just the digital to analog converter, sort of conditioning circuit, which is offset and gain and that sort of thing, and then a VCO, and that was pretty much how I got started, which was the first couple of chips around here. So just give you a tour of now what's on the board. There's quite a lot going on now. So the DAC condition is actually over on this board now, so it's over on its own op amp. Just give a bit of isolation. That's going to be quite a critical circuit because it's very low amounts of millivolts, makes quite a huge difference in terms of the tuning stability and so on. So having that on its own has helped a little bit. Laying that out on a PCB will be quite critical to get right. Over here is the brains of the outfit. So this is a SAM3X processor, so it's an ARM processor. Basically, and there's only one of the digital to analog converters used, and then everything's multiplex and sampled and held from there. And then currently there's about 7 digital control signals coming off it as well, which runs the whole show. And then over on this board, that's mainly used for pulse width modulation control and some of the output buffering, just for a very basic output stage. We've got some power supplies. They're generating minus and plus 5 volts analog, which use the reference voltages. The main power is actually coming from my bench supply over there, which is plus minus 15 supply, and digital supply as well, but I'm not currently using that because it's USB powered over here right now. And then in the middle is the main shebang over here. That's the where's my finger? That's the VCO, so it's an AS3340 VCO, so it's a clone of the CEM3340. Underneath that is a CMOS switch, which is basically used to select which of the waveforms are mixed together from the VCO. We've then got some more op amps over there, which are used as pre and post VCA and VCF buffer stages. We've got the VCF down there on the bottom, so that's an AS3320, and then up here is the VCA, which is a V2464 Cool Audio chip. And over here we've got some level shifters, because basically this board operates at 3.3 volts digital output, and all the analog stuff needs 15 volt switching references. So basically I've got some level shifters to go from 3.3 volts up to 15 volts, which is quite cool. I thought I might have to use multi-stage level shifting at one point, but I've managed to arrange the reference voltages for each side of the level shift to be compatible with 3.3 volts to 15 volts. We've then got multiplexer, so there's going to be loads of them when it's finally done, generating all control signals. We've then got some of the sample and hold circuits, so basically as the multiplexer generates voltages, these hold whatever voltage is generated for things like the pitch, pulse width, VCF, control, VCF resonance, the 2 VCA circuits, and so on. And that over there is again another level shifter for more digital signals. So effectively what we've got running at the moment is one oscillator. There will be 3 oscillators per voice mixed in. We've got waveform select. We've got 2 VCA stages. So there's a VCA before the VCF that's used to control the level of each oscillator. So there will be an independent VCA per each oscillator, so you can select different waveforms on each oscillator and then mix them at different levels into the filter. There's then a single VCF per voice, and then a final pair of VCAs on each voice, which allows left and right envelope generation. So it'll be the envelope generator and also the ability to pan each voice in a stereo field. So I'm hoping it'll be quite a thick sound when it's done. So what I've got running so far is basically MIDI over USB. So because I haven't put a 5-pinned in MIDI input, but that'll be trivial to do, just haven't got around to doing it yet. So I'm just using the laptop to generate MIDI events over here. All the voice generation, all of the control signal generation is all done on the ARM board. I've also got a terminal set up here where I can fire serial commands into this, because obviously there's no switches or anything rigged up yet, but I can turn on and off different waveforms. I can set the VCA levels and so on. There's a few things happening in Lfos. So we've got an LFO in software running the ARM board, controlling the pulse width to give that sort of thickening up sound. I've got an LFO running resonance, just so it's doing something basically, and then the rest I've got controlled. So out of reason, I've just got a pattern running. I've also got a knob assigned here. So one of the things I've done is set up a continuous controller on the VCF cutoff frequency, just so I can have a real knob, well, you know, a software knob to play with. All that's doing is sending the MIDI control information to the ARM board, which then in turn arranges the control voltage for VCF. So if I start turning on some of the oscillators, if I go back to my serial console, basically I'll toggle on and off various oscillators. So press S, we're getting the right bit, press S, and turn my saw waveform on, and you see some traces here. I'm using my old scope, I've got my nice new scope on the top as well now. Top trace is basically just prior to the VCF, so you can see it's a nice saw waveform as you might expect. And then what I can do here is change the VCA level just by entering 0 to 9 at the moment. So that's almost off, so it's, you can hardly hear it now because it's off, and then I can gradually increase the volume. And if I go all the way up, then that's starting to overdrive the filter. So you can kind of see that's normal, and it just starts to clip. You see the top trace rounding off. So if I turn off the saw, so I've got triangular waveform. Again, that's overdriven, so wind the VCA down a little bit. It's looking okay. And overdrive it. Turn that off, and then pulse waveform. So you can hear and see the pulse width modulation happening on the top trace. And then again, if I overdrive it, there we go. And I can do things like turn on pulse and saw. So that's now a mixed waveform. There is one thing I've noticed, which I'm not quite sure whether it's how I'm using it or an artifact of the AS3340 chip, but it seems to be really sensitive to do with how the pulse width modulation is used. Followed the data sheet, put the right correct resistor in on the pulse output, but basically it seems to change the pitch very slightly when you're doing pulse width modulation, and some of the values that should be fine for pulse width modulation seem to make the oscillator go a bit crazy. So I'm kind of reaching the limits where I can investigate any more stuff in this way, because to be honest, there's that many connections on this board, and it's just so unreliable in terms of you basically touch any of the connections and the contacts are really intermittent. I really hate breadboards for that, so I think I'm kind of reaching a limit whereby I've proved the software, I've got music going, I mean it's recognisable. That's the bass line of Gary Newman's Metal, if you don't know what it is. But you know, I can't really do much more with this now, so it's going to be over to doing full PCB designs next, and there'll be lots and lots of fun doing that, and many hours banging my head against a brick wall trying to route everything. As you can imagine, this is only one oscillator and one voice and a small amount of multiplexing and sample and hold circuitry. There's going to be 24 oscillators and 8 voices, in there. So that's going to be 4 voice boards. Each voice board's going to do 2 voices and 6 oscillators. So quite a lot. I think there's about 350 parts on each voice board, to give you an idea. And there's going to be 4 of them. And then I've got a motherboard which is going to house the digital circuitry, some of the final VCA circuitry, MIDI in and out, that kind of stuff. And then obviously eventually control panels with pots and switches and a key bed and all of that. That'll be relatively okay, I think. All of the schematics that I've designed already, I've been going through and building parts of them to validate what I've been doing, but it's been good fun. It's been a bit of a nightmare at times when things haven't gone so well, or things have worked one day and I've come back and there's been an issue with connectivity on the breadboard and it hasn't worked. But, you know, we have music. That's all 3 oscillators on now, and quite a lot of overdrive. But there you go. This is going to be my synth one day.